Let's do it. Katie, can you turn off the one that says, I can't remember now, I think it's one on the right? All right. So yeah, we got to this point, and I'm hoping that past this point is easy, especially because this is polynomial. So, this problem here, if you try to start setting it up using shell method, well, let's first graph this region that we're talking about. So the region doesn't care what method you use. But I wanted to graph this really semi-quickly. X equals 0 is what now? The y-axis. I like it. Y equals 4. Good gas, so that's one boundary of it there. So it's between those two. And then I want this guy. So really, if this is one of the boundaries, does it make sense? I want to see where this does what? Two things, actually. I want to see where it hits one boundary and the other boundary, so I see exactly what region I'm talking about. So this boundary is defined by y equals 4. So when does this hit that boundary? How would I figure that out?
When equals 4.
No way. So you plug a 4 in for y. Bless you. So if you plug a 4 in for y, what do I get here? Whoa. Okay, divide by 3. E minus 1, right? Is that cool? Yummy. That's gross looking. So that's one indication of something possibly. So what is that roughly? I mean, what does it come out to be? A little more than 2 maybe? Or a little more than 3? No, a little more than 2.
2.79.
Oh, okay. So in the middle. Alright. So 2, so it's about right here. So for this x value, it hits there. Now when is it 0? What happens when x is 0? What did I say just a minute ago? X equals 0 is the what axis?
0.
Y axis.
0.
So when x is 0, I get 0. I like it. So that's 0, 0. Cool. And then I just have to fill in the middle what a log looks like. What a natural log looks like.
Is that about between 2 and 3 for the time?
What am I at? Sorry?
For the e to the 4 minus 1.
Yeah, it's like 2.7 for x, right?
Oh.
That's like 2.7. Just to see about where that is, where it hits. And then what shape does it take on in the middle? What does a log look like? I want to hear somebody say it. It's a piece of wood. It's roughly like that. So it's got that concave down feature going on. So this is the region we're talking about right there. And I want to rotate that around the y-axis. So I'm going to get this curvy cone looking thing. I like it. So we have both methods available to us now. So now we have to start to figure out what is it about the problem that's going to tell me which method to use. If I wanted to use shell method, So if I wanted to use shell method, the interval would have to be interval d what? Dx. Like, because washer method, or disk method, sorry, would be agrees with the axis that you rotate around. So disk method, if you're rotating around something parallel to the y-axis, or the y-axis itself, it'll be dy, right? Shell method is perpendicular to it, is how you locate the shells. So that'll be dx in this case. So that's going to help me determine possibly which way I want to go. So imagine this. If I wanted to use shell method, I would need in here a function in terms of x. Cool. So I would leave this alone, but can I integrate ln? Well, let me say, can we integrate ln?
Yeah.
Neat. Do it. Let me show me. What's the integral of ln of x? Do it.
Just kidding.
Do it. No? No, you can't do that shit. You don't know what ln is.
But you said excellent x when you
I did, but can you do it? And we're not even going to get that, are we? I'm just trying to get a feel for which method seems like it's going to work for me. I know that if I use shell method, it'll be dx. Is everybody cool with that right there? Disk method agrees with what I'm rotating around. So I'm rotating around something parallel to the y-axis. Disk method is dy. X-axis, this method is dx. Shell is just the other way. And that's why it can handle what disk method can't. Okay, maybe. So if I wanted to use shells, I'd have to leave this the way it is. And shell method is basically 2 pi r. R would be x ln of it. So it's even worse than what I was saying. Just because somebody remembered I told you what the interval of ln was. Well, what's the interval of x ln x? You definitely don't know. I really... So now that we've talked about both methods, obviously the next important thing is, when do I know to use which method? Well, if you start to set up the interval for shell method on this, I get an interval I can't do. Decision made. I don't want to use shell method then. I can't use shell method. It leads me to a dead end. So I'm going to use this method. So I can focus all my attention. And if this method doesn't work, then maybe I made a mistake studying the shell method, but probably not. So you might pick one and you might think it's going to work, and you set up the interval and you get to a point where you're like, I can't do this interval. All right, well then go back and do the other method.
Could you have drawn like the full rotation, the full picture, and then decide what method to use?
The full picture wouldn't help you determine which way to go. I really want this to make sense, because there are other functions that have this kind of curvature. Like if I put a square root function here, I could do this all day. I could do x times the square root of x, because then I can just write that as x to the 3/2. I can integrate that all day long, right? And it looks very similar to this. And when I rotate it, they'll look remarkably similar. Does that make sense?
Yeah.
So that doesn't help you determine it. It really comes down to, is the function something that I know how to integrate? And this x ln x stuff, we have no idea. We do not know. You guys, do you see why I don't know? Why can you not integrate x ln x? Can you use u substitution?
No.
What's missing that needs to be in there for this to make some kind of sense for you? If u is ln, I would need a 1 over x. That's no good. Does that make sense? Alright, so it's weird to say this, but it's so true. It is difficult at the beginning to know exactly which intervals you can't do. It's really not an easy thing for you to figure out which intervals you can't do just by looking at it. And if you start to work it out, you don't know if it's because you can't, like nobody could do it, or is it just me that can't do it, right? That's another thing to figure out. Is it just me, or is this not possible? So I'm trying to give you guys a little leeway, but also you've got to realize that that's something to work on. Got to really, if you want to use... Obviously, I can't just integrate this like if I say interval of cosine. That I don't need any method for. I know what it is. But then you look at it and go, if I wanted to use the only other method I know, which is u sub, I ain't got what I need. So that's... Right? I ain't got grammar either, but we'll move past that. Alright. So I know I want to use disk method because the shell method leads me to something nobody could do with the amount of knowledge that I in this class have, right? It's not just me. So what would disk method, so I know it looks like integral dy. So what's the very first thing then I need to do over here? Yeah, get it in terms of y. I like it. So take a minute and do that. Solve that equation for x. What do you do after this step here?
So E.
Yeah, raise each side to e, or e to each side. I mean, it's basically what we just did to solve when y was 4. In fact, my y looks like 4, so it really looks like the same thing. So x equals e to the y over 3 minus 1, right? Okay, so that's the function we're using. How are you going to do this, Jeff? I don't know. All right, there it is. And so identifying, so what does that mean? How am I going to find my disks? I told myself how. dy, right? So if I go any y between this, and what's nice here, another indicator was, what I meant by this might be an indicator of which method. That would, if I use dx, that would be one of the limits. Not impossible, doesn't mean it's, but that's a good sign that maybe that's not the way I need to go here, because that's not a really nice number to look at. But now what are my limits going to be?
From 0 to 4.
Yeah, because my y's go from 0 to 4. So any y in between would indicate a disk sitting there. And what would the radius of that disk be? The function value. I love it. Because the area, the region I'm talking about is hugging the rotation axis. Does that phrase I just used make sense?
So it was translated over, those subtract.
Exactly. You have to add or subtract something off if I moved it away from there. I like it. So then, how do I do disk method? What's it based on? What's the basic idea? Areas of circles. So I know that would be pi r squared, where r is this business here. My radius is my function value. So pi r squared. Can we, and that's trying to be a y. It's trying. The poor little dude has no chance with me. And now, this is where people make really simple mistakes. How do I FOIL this thing? What's e to the y over 3 times e to the y over 3? Yes, cool. You just add the powers, right? Don't make new rules. Don't make it y squared over 9. You add the powers, so you get e to the 2y over 3. Minus e to the y over 3, minus e is minus 2, e to the y over 3, plus 1. Is that cool? Just foiling it out. And now let's see if, try to do that next step. This is interesting. You don't need USEL. You actually could use it, but try not to. Let's see what happens. Integrate that bad boy. Again, y is just one of the two biggies, and it's one I can't make very well. this should sort of feel like integrating x to the 2/3 or something, because when you integrate this, it wants to be itself. But what would come down in a way for chain rule if I did that guy's derivative?
2/3.
So then what do I have to have outside to kill it?
3/3.
3x. So see how it feels a little bit like, multiply with the reciprocal of the new power. It isn't, but it feels like it. And then, so what happens here?
-6
6, good. E to the y over 3 plus
X.
y.
y.
Yeah, well,
And this is a good example of being careful when one of your limits is 0, it's not always going to go away. You have these stupid e's in there. So what do we get? We get pi in front of 3/2 e to the 8/3 minus 6e to the 4/3 plus 4. Just plug in a 4 in, right? It's easy because I don't know what those are, so I just write them. Minus, what do you get when you plug a 0 in?
1.
Yeah, 3/2 times 1. So it'll be minus 3/2 plus, is it cool? Minus a negative. What happens when you plug a 0 in? E to the 0 is times 6. 6, alright. And the y, of course, is 0.
what do you think this is? Or are you switching it?
Yeah. Sorry, but yeah, it's got to be minus, so it's really minus the other side. Just change the signs as I went. And then that you could plug in your calculator or whatever. Cool. I like it. Especially if you want to plug this function in your calculator and double check. You want to make it into a decimal so you can double check. Alright. But once you get the integral set up, the rest of the problem should be the easy part. Okay, so let's finally do the thing that's on this sheet. It's been staring us in the face for a while. Or, sitting in our bags or whatever the hell. So why don't you guys go ahead and try to do that. Try to determine which is the best method. And the reason I always try to shelf, because if shelf's going to work, I like it better because it doesn't have any squares in there and you don't need outer inner radius crap. Alright, so let me see if you guys... I'm rotating this around the y-axis. Anybody need a copy of this? Anybody not have theirs with them? Okay. So maybe guys, anybody choose shells? No? Do you use discs? I don't know. If we look at shells first, let me show you. I'm rotating around the y-axis, right? So when I draw in a representative rectangle, what's going to happen to it? It needs to fill in this area that I'm talking about. So I'm rotating this way, so my rectangle has to be perpendicular to that, or parallel to that, I guess you'd say. So it's got to be like this. But the beautiful thing is I just draw it from top to bottom like that. So I mean, how tall is that rectangle? What's the height of that rectangle?
1.5 minus.
And real quick, just to keep us focused correctly, if I'm using shells, it'll be integral d what?
Yeah.
Dx. So you think about discs first. Discs will want to be dy because it's y-axis. So shells must be the opposite. dx. I like it. So what is this height? So everything inside is going to be in terms of x. So how tall is this thing? It's from
The top function.
the top function minus the bottom function. So I very nicely have identified those. So my height is going to be square root of x minus 1 minus x minus 1 squared. So that seems to be a drawback. That's kind of gross. I need more room in my integral. And what else do I need to know? What's the radius going to be? So here's the axis of rotation, and there's my arbitrary kind of random rectangle. So my radius is going to be just x. It only changes if my rotation axis is different than the y or x axis. So then my radius is going to be x. So putting this bad boy together, I get 2 pi r h. Oh, get in there. Time, just dx. Okay. Let's let that sit there for a second. Can you guys see possible problems in trying to do this? I mean, this first part is not impossible to do at all, but it looks worse than I really hoped for, right? So what about this? Who tried? Who's got discs going on? What do we got going on here? Discs would want to be integral dy, because they agree with the rotation axis, right? That's the idea with discs. So I need to identify the radii, but I also need everything to be in terms of y. Well, that's the sucky part about this method, right?
Do you use washer? Washer?
Yeah, I'm going to have to use washer. I'm going to have to get an R outer and an R inner. All right, maybe. Just to see what these both look like, right? So what would so first off, what would this function look like if I solve for x?
Y squared.
Y squared minus
Yeah, so x equals y squared
plus 1 plus
plus 1. Where are you at? There you are. All right. And what about this guy? Noticing that it's the positive side of that, right? It's this side of this. So you don't have to worry about the plus or minus. You see, you guys understand what I'm saying? So the minute you take a square root, you really should have to put plus or minus, right? And then it would be 1 plus or minus square root of y equals x. Thankfully, I can choose one of those for it to be true, and this side is where x is smaller than 1. I really want this to make sense. X here is smaller than 1, right? So for that y value, it must be 1 minus rad y. So that's not what I want. I don't want that side. I want them up here. I want the ones bigger than 1. So I want the ones where x is bigger than 1. That's what I want. Of course, when you have to solve for a variable, it kind of sucks when your original function is not invertible. It's not technically invertible, but thank God we're only talking about one side of it that is invertible. It does pass the horizontal line test because I'm not including the other part of the parabola in this. Are you guys semi-understanding the words coming out of my face? Yes, okay. Cool. I got a lot of ideas going on, but that's calculus. All right. So now I've got these in terms of y. So what do I need to figure out now? Yes, good. My outer radius, my inner radius. So I started my axis of rotation, and I go out, and the first thing I hit, this guy. So this will be my inner radius. My inner radius. And of course, that's what?
Minus
Y squared plus 1. Right? Because we got to use the in terms of y for this method here, right? And so our outer is going to be what? Yeah, 1 plus square root of 1. Cool. So now I got everything I need to put this thing together. So in general, it's going to be
Minus.
yeah, r outer squared minus r inner squared. So r outer squared minus r inner squared. So those are our choices. They both will work. Which one seems to be easier mathematically, do you think? And I haven't even done the limits here, I should. The nice thing, what are the limits for this one here, dx? What is x doing? 1 to 2, kick ass. And for the other one, it'll be dy. So what are the y's doing? 0 to 1, kick ass. So that's the importance of drawing the region decently well. You got to know the extremes so you can identify the limits. So we identified a problem up here, right? I don't know if you guys can see that's going to be an issue. It's not a big issue, but still it's an issue. So down here, this one just takes some foiling, but beyond that, it's going to be relatively easy to integrate. Do you guys see that?
The square root of this will go away, right?
Well, yeah, at least on one term, right? It'll still be there in the middle term, but it's just y to the 1/2. Who cares? But this method, of course, this method is really cool when it's just a radical of something, period, because then the square just kills that for you. That's awesome. Maybe. So which method do you guys want to do? I'll do the other method. You guys want to do this method? I'll let you choose one. I'm going to do the shell method, because I think less people might choose that. Choose one, and let's see if we get the same answer at the end.
There's still.
Sorry, what's up?
I know. I said about like opening it, and there's gonna be 2 square root of y.
Yep, that's right.
I don't know.
And it'll be fine. 2y to the 1/2. Yeah, okay. So you can integrate that bad boy. Alright, let's see. I missed my, yeah, my 2 pi is still out there. 2 pi, 2 pi. So I get 58 pi or 600.